Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. In this session we will create a communication link between these both LoRa modules. It is RYLR998. I explained the datasheet in video number 785, and today we will program it to define transmitter and receiver and different frequency settings, transmitter ID, network ID, receiver ID, and we will make a transmitter using this Arduino, and we will transmit some data and we will receive at a frequency link, at a wireless link to this module. Then we can assign different functions and we can use this transmitter and receiver for useful function. To program these LoRa modules, we need a USB to TTL converter that will transmit this data from USB port. We will connect this module to USB port and we will connect these 4 wires to the LoRa module to assign different parameters to this module. I explained how we can configure this module in the software in the computer Windows, in the Windows based system. You can watch that video, that is video number 791. How we will connect this module with LoRa. We have USB to TTL converter here. Here we have 3V3. It will go to VDD pin here. This is our USB to TTL, and here is LoRa module. The first wire 3.3 volt we will connect to this module, and we will build all the project step by step. If you are interested, you can watch this video, otherwise you can skip. Then there is TX, that is output of this module. So this is output, it will go to input and we will connect to RXD input. The third pin from the top side. Here is reset pin, we are not going to use reset pin. So TXD will go to RXD, and then there is RXD pin, it will go to TXD pin. So from here it is transmitting data and this module will receive data. That is this yellow wire. You will need female to female header wires. Then there is ground pin. Ground we will connect to ground, and here is 5 volt. We will not use this pin. Be sure that this module works at 3.3 volt. Never apply 5 volt, otherwise this module will damage. This module is ready to connect with computer. So it is for this. If you are using ftdi module, at that time you need to make jumper for 3.3 volt, but this time this module have separate pin 3V3, so 3V3 we will connect as a VDD here. Now open the Arduino IDE. Now I will plug into the USB port. It have detected the port COM5, select it. Now go to serial monitor. Now go to Google, RYLR998 AT command, download this document. I will download it here. Go to downloads, show in folder, open this document. And I opened this document in the side window. of this serial port. Serial port is here now, and we will read this document. When we want to build a communication network, we need frequency, that is called band, frequency band, because it is working at GSM frequency 915 megahertz. For that purpose, you need to verify, you need to check the allowed frequency band for LoRa. I will go to internet and I will ask LoRa wireless area network Pakistan, what is the allowed band? Because it is a wireless communication. For wireless communication, you must follow the allowed frequency band for the network in your country. There are some dedicated bands for that communication, comments and rules and regulations. Read more. Frequency plans by country. Go to this list and check the frequency band for your country. For example, Argentina 915 to 928 megahertz. This is for LoRa wireless area network. For Canada 902 to 928. These are the dedicated bands. If there is no frequency mentioned, then you have to check your telecommunication authority in your country. For example, in India, it is 865 to 867 megahertz. For my country, for Pakistan, there is no allowed frequency here. Now, I will go to PTA, Pakistan Telecommunication Authority. Yes, here is Telecommunication Authority, that is here. I will check these two documentations here. In some conditions, we need some special approval. Yes, here we can see for Pakistan, it is 868 megahertz and 915 megahertz. We can use these two bands. Okay, then there is a special permission. If you want to build a special project, at that time you will need to check your telecommunication authority to take license. It is application form for license based on IoT services. But for my condition, because this is our educational video, we are not going to transmit some critical data, so we will use 915 megahertz, that is standard frequency. Okay, we will transmit some data. 915 megahertz. Then we will create a network, and each network, it have its ID, network ID. In this frequency, in this network ID, we will create our LoRa modules, and each LoRa module, each transmitter and receiver, it have its unique address. For example, this one it have 1, this one it have 15, this one 19, whatsoever, this one is 9. We will see in the command set how we can assign these. We will program this one. We can use as a transmitter, we can use as a receiver. For this module, I will use frequency band 915 megahertz. Type here AT in capital. We can see it is showing some garbage. Why? Because it have baud rate, standard baud rate 115200. So in the serial monitor, you will need to set 115200 baud rate. Now AT, it will say okay, that's good. AT, yes, now it's okay. That means we can program, we can communicate this module. Now Let's read the document. This is applicable for these two modules, 998 and 498. All commands to program this module will be followed by AT commands, AT plus address, and then we will add some suffix to these commands to take useful function. AT plus network ID, AT plus band, AT plus parameter. And then there are different things, AT plus send, how we will send data, AT command set. First command we set AT. When we set AT, that means it is communicating, it will return with OK. That is response from this module. Then if we want to reset this module, we will type here AT plus reset, it will make reset. And if we say AT plus factory, it will make factory reset. AT plus reset, yes, reset and ready. AT plus factory. Now it will erase all the predefined parameters. If I already programmed for some other parameters, now it is back to factory reset. Now we need to check AT plus mod. This is our first setting. And when we will ask this module, when we take a query, when we send some question to this module, we will send with question mark. Enter. Mod must be 0. If it is 0, that means it is ready to transmit or receive. And if it is set to 1, that time the module will go in sleep mode. We will set frequency AT plus band question mark 915. If you want to change it, AT plus some other frequency, AT plus band is equal to 868 megahertz. Add 6 zeros, 1 2 3 4 5 6. Enter. It will return with OK, that the command is accepted. AT plus band question mark enter. Now it gives new frequency, but we want to set this frequency. AT plus band is equal to 915 megahertz. Enter. Now frequency is this. We will create network ID. Now we will create network ID. So network ID is from 3 to 15. We can set these IDs, and the default setting, that is 18. If I will say here AT plus network ID question mark, it is saying it belongs to network ID 18. We will create some other ID. For example, I want to set AT plus network ID is equal to, for example, I want to create network ID 8. Enter. Network ID 8. All the modules within this range, these can communicate to each other. If we have another network here that have ID, network ID 7, any module or all module cannot communicate with this one. So in this network, how many modules we are going to connect? This will belong to network ID 8. Then each module will have its own address. For example, I will set AT plus address question mark. It is 0. Default setting is 0. So we can assign 0 to 65,535 addresses. We can assign any unique number to this module. So I will set AT plus address is equal to, for example, I will say 99. Enter. AT plus address question mark. What is address now? address is 99. Now then there is communication rate, UART communication rate, serial communication, AT plus IPR, 11500, but we need to set our standard frequency for the Arduino Uno. AT plus IPR is equal to 9600, enter. IPR 9600. Now this module will communicate at 9600, and if I will type here AT, it will not give response because this module is now set to 9600, and if we see here our this terminal, it is 11500, so we will set frequency band 9600 to communicate this computer with this module. Now if I will set AT, it is saying okay. That means the baud rate is now configured. Now this is our one module. Same way we will set the other module. VDD, RXD, TXD, ground. Now I will plug this module here and I will open the COM port. COM port is selected, and now I will select here serial monitor. AT, enter. Same garbage, we will use here 11500, that is the standard baud rate for this module because we are using it first time. So we will set the same parameters, band 915 MHz, mode 0, network ID to 8, and we will set address, we can say 101, and we will set IPR baud rate to 9600. Let's do it. AT, enter. AT plus band question mark 9500, the same frequency. AT plus mod question mark mod 0, that's good. AT plus network ID, AT plus network ID question mark 8, that's good. So AT plus address is equal to 101, enter. AT plus verify the address again by question mark, so 101, that's good. And AT plus IPR is equal to 9600, enter. AT, now it is not communicating, so change the baud rate from here to communicate again. AT, enter, plus IPR question mark, enter. So that's good. If you will not add question mark, it will say error number 4. So our both modules are now programmed. Now let's build Arduino project. We will open two projects here, blank projects. I will use this module here and this module here. We will transmit data from here and we will receive here. Let's make connections as a transmitter and receiver. We have serial port here. We will create another serial port because if we will occupy this serial port, that time we will not able to program, we will not monitor the data from this Arduino. In the both projects The left side project, that is transmitter, and this will receiver. Sketch, include library, add here software serial. The same way, add here sketch, add library, software serial. What will the function of this software serial? Copy. It will become, and we will define pin 2 as a receiver in 2, 3. We will use these two pins, terminate with semicolon and give a comment, 2 for receiver in and pin number 3 for transmitter out. So these are the pin definitions. We will copy the same statement from this side and we will paste here. For example, we want to build a oscillator here, flasher here. We will indicate LED. We will create a LED connection here and this LED will turn on, and then we will transmit from this module and we will receive here and we will use the same LED here. Let's build project here. For example, I want to build LED, integer LED. I want to connect to pin number 4. Terminate. Let's build LED. This module is here. This LED. I will connect anode pin to pin number 4, which we are writing in the software. And I will use 1 kilo ohm resistor to the cathode of this LED. Anode of this LED will go to pin number 4. 0, 1, 2, 3 and 4. And we will connect the ground side of this resistor to the ground of this Arduino board. Yes, that's good. Now we will define the function of this LED in the setup. Pin mode LED, output. Now we will say digital write where LED, high, bracket closed, and we will give a delay of 1500 millisecond, 1.5 second. Digital write LED, low, terminate, then delay 1500. We will turn on this LED with this rate, and after that we will send this data to the LoRa module. First of all, we will turn on this LED. I will connect to this USB port and tools, port, COM3 Arduino. Type here LoRa Project TX transmitter. I am uploading this code in the board, so it must start to blink. Yes, that's good. Now same way we will create this board as a receiver. First I will create the same LED assignment here. I will connect 1 kilo ohm resistor with LED cathode, and we will connect this resistor and to the ground of this module, and we will connect anode to pin number 7. Okay, we will take output from pin number 7. Integer LED is equal to 7 terminate. So we will copy this statement here. Pin mod LED output. Now it is time to modify this project. Here we will start serial.begin at 9600 terminate. If we want to monitor any data which we will write to this module, we will say serial.begin and we will copy the same statement here. Now this port, transmitter receiver port, will communicate with the computer, and we will say LoRa.begin at the same 9600 terminate. Copy, and here we will paste here. Now both serial ports, this serial port and this serial port, we programmed for serial communication. Now we want to transmit data from this terminal, from here. Now we will connect this module with this board. We will use male to female header. Female pin, the ground pin, will connect it to ground, and this ground will come here at ground pin. We will connect ground from here, and we will provide 3.3 volt supply from this board. Remember that never apply 5 volt supply, otherwise you will damage the LoRa module. 5 volt, this is 3.3 volt. I applied 3.3 volt supply to this module. Now we want to transmit data from this module, from this IC to this module. It have 5 volt TTL level, and this have 3.3 volt input, and its logic level that will 0.7 multiplied by VDD, and its input level will equal to 0.7 multiplied with VDD voltage. To attenuate this 5 volt serial signal, I will use a voltage divider network. You can use 3.3k resistor or 4.7k resistor, that will much better, but this time I am using 1 kilo ohm resistors in series, 2 resistors in series. Let me define the connections. This is our Arduino, and here we have LoRa module. 3.3 volt from this pin will go to VDD. Ground will go to ground. As in software, we defined that pin number 3, digital IO pin number 3, that is output pin, that is transmitter out. So transmitter out will come to a voltage divider network, 1 kilo ohm, 1 kilo ohm, and take the center point to RXD. We will take the center point of these two resistors, so we will take 5 volt here, we will apply to ground, 2 resistors. Here we will receive 2.5 volt signal. Let's connect here. So resistor this end we will connect to ground pin, and we will connect pin number 3 to this resistor. So pin 3 I connected to this resistor, and the center point of these two resistors. Now it will go to RxD. This is output. Pin number 3 is output. It is now attenuated at 2.5 volt when it will send signal. So this voltage divider will provide 2.5 volt signal to this receiver pin. This transmitter signal will go to receiver and this receiver will go to transmitter, and it will transmit from this antenna. Now this is the connection for this module, and now we will make connections for this module here. The same 3.3 volt will go to VDD for LORA module. Ground will go to ground, and pin number 2, that is receiver in, it will go to TXD of LORA. So we will connect directly transmitter pin because it have 3.3 volt output. So this module will work safely. This is ground pin. We will connect ground with the ground, and we will connect VDD to 3.3 volt. Carefully connect to 3.3 volt port, and we will connect TXD pin from here, and we will connect to pin number 2, 0, 1, 2. This is now ready to transmit data, and this is now ready to receive data. I will connect this cable here, USB cable here. After LED turn on, give a delay for 200 millisecond or 100 millisecond. 200 milliseconds, that's good. Now LoRa.println, this is command that we are asking this IC to send data to serial port. In inverted commas AT plus send, this is the command syntax, is equal to the listening address, that is 99, where it will send. This module will send data to module 99, this address. We will use this address 99, comma, what we want to send. We want to send, for example, HI, high. We will say that is payload. So payload is 2, comma, that are number of characters, 2, HI, high, inverted commas, bracket close, AT plus send is equal to 99, that is the address of the listening end, this one, and we will say 2 and high. Same way, we will copy these two statements from here. When the LED will turn off, at that time it will say LO low. Now move to the receiver end. The same way, we are transmitting data from this point and we will receive here. Here in the loop, we will say if LoRa communication is available, what it will do. We need to store this data in some string, and we will name that string as a incoming string. Incoming data string is equal to incoming string. So we assigned a variable name to the string. This will equal to LoRa dot read string. Any data coming from the LoRa serial communication, LoRa wireless, this command will receive data and it will store in this string. Now we will assign a character array, char character. We will say data array and we will give a length, for maximum length 20. That's good. Incoming string dot to character array, data array, comma 20. Character static sign, data is equal to string token, data array, put this data in token. We want to print this data to serial port. We read this data. If LoRa wireless communication is available, we will read that string into this string name, and then it is converted into character array, and this character array is converted into data, and now we will send this data serial dot print ln data. Yes, that's good. I think first we will read this data from the serial communication and we will program it. Tools, select to COM4. Now this COM4 selected and we will program it. LoRa Project RX. And now we will update this program because now we are programming this module to send data on the wireless module. Yes, that's ready. And now we will open the serial port here at COM4. COM4, tools, serial monitor. Yes, wonderful. It is now receiving low, high. When the LED is low, it will say low, high, low, high. So we are transmitting the LED condition and we are receiving here. That's good. Okay, let's stop it. And now after serial printing, we will compare this string now. String compare, CMP, string compare data high 0 Now we compare the string what we received. If it is equal to high, what we want to do, digital write where LED comma high terminated. Yes, that's good. And now we will copy the same statement here. If it is low, if incoming data is equal to low, what we want to do, we will digital write LED low. If the data is low, the LED will turn off. Let's program again. COM4 selected. Yes, good. Program it. Yes, that's good. Now it is ready to communicate, and at each turn on this LED must turn on. Let's power on both boards. Wonderful. We can see now this LED is turned on, and meanwhile we will use serial monitor. The same way we are receiving the data, low, high, and it is working with sequentially. We can transmit any data from here to here. The same way we can program the transmitter protocol, and we will transmit data and we can receive it here. In our upcoming projects we will do the same. We will take some data from here, we will send it here, we will take a useful function. After that we will receive feedback from this module. I will add the links of these source codes in the video description. You can use it. I hope so this video is informative. If it is informative, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.